2-2 would seem very different from 2-1. 2-1 was systems of equations and solving them. And then all of a sudden we're talking about matrices, which would be the plural of matrix. Right? And it seems completely unrelated, but as we go through this chapter, you're going to find out how they are very much related. The systems I gave you for yesterday were what are called a 2-by-2 system. There were 2 equations and 2 unknowns. So the elimination method, graphing, and substitution work very, very well on those. Once we start talking 3-by-3, 4-by-4, 10-by-10, those get to be rather tedious if you do them by hand. And so we're going to let maybe some technology help us out. But the technology that's going to help us out needs us to understand matrices. Okay? And so once we get this done, we'll be able to solve some really, really hard questions very quickly, okay? With the help of technology. A matrix is simply an array of terms that are normally called elements. My kids in 1st and 3rd grade are now dealing with arrays, but they're doing kind of more multiplication, like 2 groups of 3 and things like that. Those are still arrays. You just draw pictures, right? But it's very helpful to know how to kind of name things. So we'll take a look at a couple here. Because to name them, we can either have a letter name for them. For example, this first one here, perhaps we would have an A underneath, and we would call that matrix A, right, sometime. Or maybe we would call this matrix B or C. Normally it's a capital letter. Obviously, this A, B, and C that I have here is just for the example. Right? Another way that we can name it or describe it is by telling its dimensions, by how big it is. So we have to tell it by the number of rows, then by the number of columns. Rows go this way. So this one has 2 rows by, if we go it the other way, how many columns it has? 2-by-2. For those that really struggle with remembering which one's rows and columns, just think of Greek or Roman architecture. The columns are the things in front that go up and down, right? And so this one, now that one was easy because they were both the same. You could kind of mess that one up and you'd still get it right, okay? But this next one, maybe not. We have to do the number of rows first, 2, by the number of columns, 1, 2, 3. Okay? This next one kind of falls back into that category. Boy, you could really mess that up and still get it right. Okay? Rows going this way, 1, 2, 3, by 1, 2, 3, 3-by-3. Now, a square matrix is a lot of times what we're going to deal with for what we want to do in the long run, because if we have a 3-by-3 system of equations or 4-by-4, you can see how that could very easily be a square matrix, because it says here a square matrix is simply a matrix with the same number of rows and columns. Of the previous matrices, are any of them square of the ones we just had? Yeah, A is, right, because it's 2-by-2, and so is C. So A and C. B up there is not because it's 2-by-3, which is very different than 3-by-2. One other thing that we might want to talk about very briefly up here is if you had to tell somebody what spot that 3 is in this matrix. We know it's a 2-by-3 matrix. How would you kind of describe to somebody what location that's in? You could say top left, but that's kind of not very accurate. You would say which row and which column. It's in row 1, column 1. So how about the 8? That's in row not 1, but row 2 and column 1, 2, 3. Right? That's how you could tell somebody where it's located, so that they could tell you which value it was. Okay. So far that's just general stuff about matrices. It is difficult for me to understand why equal matrices are trouble. I really think it boils down to our understanding of a word that you think you know very well. Equal. Okay. Equal in this case means ends up with the same value. Okay. So if you look right here, row 1, column 1, and row 1, column 1, guess what? They are equal. I think people look at this first one and are like, oh, equal matrices, those are simple. Okay. But then they look at the second one and things get very confusing very quickly. But if you take a look at row 1, column 1, and this one is y minus 3. And it has to equal, see it's just sliding right down there, row 1, column 1 of this one, x. And if we want to color code things, now we're at row 2, column 1 is a y, better equal row 2, column 1, which is 2x. Now it has to make both of those true at the same time for these matrices to be equal. Well, luckily we had 2-1 to help us out with something like this. This one sets up for which of the methods? We've got graphing, Elimination or substitution? Yeah. Substitution, yeah. Graphing, almost. The second one's really good for graphing, but not so much the first one. And in fact, they're both set up for substitution, so it doesn't even matter which way you try and substitute. I would probably take this one, what x is, and put it right there. That's probably how I would do it. So y equals, here's the 2. And we're going to replace x with what it's supposed to be. Here it says x equals y minus 3. So if we bring our work over here, y equals, we've got to distribute that 2y minus 6. So again, the whole idea is to go from 2 variables to 1, something that we can solve. I would probably actually just subtract 2y this time. Hopefully you're not too nervous about that. It is 1y minus 2y is negative y equals negative 6. Now a lot of you were probably taught, oh, if negative y equals negative 6, then positive y has to equal positive 6. But does anybody know algebraically why that has to be true? Yeah. Yeah, there's a negative 1 kind of sitting there, so can I get rid of a negative 1? Well, yeah, you can divide by negative 1 on both sides, right? Then over here they cancel. Y equals, and a negative divided by a negative is positive, so it's positive 6. Well, now that I know y is positive 6, can I go figure out the x value? Yeah, come right back to here. So put 6 in place of y, right there. So 6 minus 3 will equal x. So x supposedly equals 3. And I would like to go back and make sure that it makes sense. So for y, I'm going to put in 6. So 6 minus 3, and then x is 3. Y is 6. And I would pick 2 times 3. What do you think? Do those matrices end up equal? Yeah, we've got 3 over 6 and 3 over 6, right? As far as the matrices are concerned. So it does work. Are we doing any questions so far? I feel like we're going very fast. Yes? Yes, the question is, what if I wanted to substitute the other way, which is to substitute basically the 2x in for y? It would work out exactly the same. Yep. Except you'd be solving for x first, and then you would go get y. Yep. Because this was one of those types where only one answer was going to be found. All right, now we're going to start with our the things we can do with matrices. We're going to start off with some of the simpler stuff, just like when you started learning about numbers. The very first thing you did was add and subtract them. Okay? So here we have matrices. Something we need to know about adding matrices is they better be the same size. Otherwise, we're going to run into trouble. So this one here, what are the dimensions of this? First, we'll call it A, and we'll call this one B so that we can talk about them. Dimensions for A. Shout it out. 3 by 2 is correct. So for us to be able to add them, B, I really hope, is 3 by 2. And it is. So if we're going to find A plus B, that's how you would notate it. Well, let's face it, if it's 3 by 2 and 3 by 2, I'm going to end up with, if I'm adding, 3 by 2. And what you do is you simply go element by element. You take row 1, column 1 from the first one, and so here's row 1, column 1, add it to row 1, column 1. So it's 2 plus a negative 5, otherwise known as negative 3. And then, does it really matter which one you go to do next? No, but I would suggest you find some kind of pattern to follow. So I'll just work my way here. I'll do row 2, column 1, and you better add it to row 2, column 1. So it's negative 1 plus a negative 4. That is a negative 5. And then we'll go to this one, row 3, column 1. 3 plus 1 is 4. And negative 4 plus 7, because that's row 1, column 2. So that's what, 3? Being very colorful here. And we'll go take negative 2 plus a negative 8, so that's negative 10. And negative 8 plus 4 is negative 4. Do you agree with my A plus B? Okay. So that's its own matrix. I could call that something else. Maybe I call that C. But that is a separate matrix from A and B. Okay. And the last one, I basically want you to take A and subtract B. over here, I want A minus B. Why don't you go ahead? I will pause the recording and go ahead and do that one right now on your own if you haven't done so already. And those listening to the recording, actually pause it and actually do it. All right, let's take a look. So I will call on an individual, but seeing I'm recording, I will just describe the outfit this person is wearing. And then I will ask for which row and column answer I would like them to give me. And then that person will decide the next person, and so forth and so on. So, individual with the UW Oshkosh Titan sweatshirt on. Could you please tell me the answer for row 2, column 1? I've been told that the answer is 3. Do you agree with that? Because it is a -1 minus a -4. So, that is 3. I agree. Who is going to be next person in the Oshkosh shirt? Yes, next person that's been chosen. Would you please tell me row 3, column 2? Is this correct? I've been told -12. -8 minus 4 is? -12 is correct. I think my pause made that person nervous. Who shall be next? And you can actually say the name because the mic probably won't pick up on it. Yes, that person seems really happy about being chosen. Row 1, column 2, please. I've been told -11. So it's -4 minus 7 is -11. That is correct. Who is next? Yeah, I get to tell you which one. Relax. Row 2, column 1. What's it? Then give you the answer. Oh. Well, how about row 3, column 1? 3 minus 1. For those listening to the recording, I believe that person was chosen because they weren't paying attention. Who will be next? All right, let's go row 1, column 1. I've been told 7, so it's 2 minus a -5 is 7. And who is next? All right. What is the answer for the last remaining location, which is row 2, column 2? The only one left. I've been told SACE. -2 minus a -8. Is that SACE? C. So A minus B. When I read these, just so you know, I will actually go across. So I would read it something like this. 7, -11, 3, 6, 2, -12. Okay. Any questions? Muy bien is not a question. That's a statement.